So now let's get into matching genetic programs to the existing conditions. Okay? So in a logical genetic strategy, all conditions should be considered before making any genetic decision. Going back to that economic model, what happens if I go with this breed? What will happen to my input cost? And how will that influence my price per pound and maybe my reproductive efficiency of that operation? So whatever you do, you've got to look at all the impacts of that. And so those conditions are climate, topography, pest, forage, labor, management skills could be another thing. And then also you have to look at the markets on how those conditions can affect it. On the genetics and forage availability is the main determinant of optimum mature body cow size, or mature cow body size. And so larger cows need more forage with that. Forage quality is the main determinant of optimum milking ability. And so higher milking cows are going to need a higher quality diet, a higher quality forage. And forage consistency is the main determinant of optimum fleshing characteristics. So lower fleshing cows need forage that's more consistent and available and quality. So there can't be these breaks in the system with that. Higher fleshing cows, they have the ability to put on extra condition when times are good, when forage condition is really good and high quality. But then they will lose some of that condition when those conditions begin to drop off. All right, so in genetics and markets, some things that we have to look at. So if those calves are sold at weaning, payments based on the weight at that point and the estimate of the future performance, as we'll talk about in the feeder cattle grading, is that the buyers, they're looking at what the future production will be. But if the calves are retained, fed, and then sold on a carcass value, producers directly benefit for how those cattle perform post-weaning. All right, so this next slide here talks about matching genetics to the conditions. And so as you can see, forage availability, high, medium, and low, and then our environmental distresses, and then some of the traits that we look for: milking ability, mature size, ability to store energy or fleshing ability, stress tolerance, calving ease, and lean to fat ratio. Dr. Steve Hammock, one of our professors here and beef cattle specialist, developed this and put this together. And so as you look at that slide, that chart that I gave you, as feed availability decreases, optimum level of milk decreases, mature size decreases, and the ability to store energy increases, so they have increased fleshing ability. Stress tolerance and calving ease don't change, and lean to fat ratio decreases as well. So as environmental stresses increase, optimum level of milk decreases. So we showed you that one picture of the spade ranches and those tough conditions. That would be a high stress environmental concern. Mature size decreases. The ability to store energy increases. Their stress tolerance increases because they're going to have to survive in those conditions. And calving ease increases because we're not going to be able to observe them as much in the calving situation because it's more of an extensive production. And lean to fat decreases as well. So that gives you an example as you move through that chart what you would see. So lower stress, higher feed conditions are more applicable to larger, higher milking cows. And higher stress, lower feed conditions are more applicable to smaller, lower milking, easy fleshing cows, like we saw there at the Spade Ranch. As we move east in Texas and we get east of I-35, we will typically see larger, higher milking type cattle. They'll be because of the higher feed conditions and more predictable weather patterns, rainfall patterns, and more predictable high quality forage. Regardless of the conditions, fitness characteristics are always important. So stress tolerance and calving ease is always something we look at and pay attention to. So only after that, after we determine the conditions, then we decide, well, what characteristics and performance levels are best to match those conditions? What breeding system are we going to use? Are we going to use a continuous or terminal breeding system? And what breeds fit into those conditions in the breeding system? And so then we begin to develop mating plans and breeding systems based on our needs of our ranch, what our environment is, what our production and management conditions are, as well as what our market's going to be as well. And so mating plans, they can be random, so no effort to control the relationships with parents. We just put a bull out there initially with the cows. The replacement females get bred back to that bull, or maybe another bull calf that was raised. It's completely random. That is not necessarily the preferential, the best way to do that. We can get some random mating in it if we're not paying attention to the sires that we're buying, the bulls that we're buying. If we're not looking at some pedigrees to see if they maybe can relate back to some replacement heifers that we're keeping. Inbreeding is mating animals more closely related than the average of the population. And the main use is in line breeding to increase the genetic influence of a superior sire dam. The downside of the inbreeding is it's the opposite of hybrid vigor. And with inbreeding, you will, one, if you have a genetic defect, you can increase the rate that it's in the herd, but also you're going to decrease performance of those cattle. You're going to decrease vigor. You're going to decrease growth. Because you think about it, it's the exact opposite of heterosis, which we just discussed. Outbreeding, so mating animals less closely related than the average of the population. So outcrossing is outbreeding within a breed. So I'm going to try to find, I've got most of my cows are this genetic makeup going back to this sire. So I'm going to have to go, if I'm a purebred breeder, go outside and find an outcross solution or outcross bull that's not related to those to put in some new genetics into my herd. Crossbreeding is outbreeding of animals of different breeds, and we see that a lot in the commercial producers there. So inbreeding, as we talked about, it's detrimental to vigor. It results in more homozygous pairs, does not increase the number or it does not increase the number of possibly undesirable recessive genes. It just increases the chance that they will exposed in the progeny. Outbreeding, especially crossbreeding, we generally improves the vigor and fitness. And that's why we utilize crossbreeding in commercial operations, as we talked about earlier. Breeding systems, one, a continuous in which the replacement females are produced within the herd, and we take those heifers and put them back into the herd. And a terminal is heifers are not retained for breeding, so replacements must be purchased or produced in another herd. And so we talked about in the earlier lecture on sire breeds, and oftentimes our sire breeds, we think about them as a continental breed that's heavier muscled, growthier type animals. But a terminal cross could be maybe a continental breed, or it could even be a British breed too. Where I think about a terminal cross is the mothers are not as productive, or the daughters are not as productive as their mothers were. So if I took, for example, we showed you the picture of that operation that started out with Beefmasters and we're using Angus bulls and keeping those females. The subsequent generations, as we began to remove the Bos indicus genetics in those replacement females by mating back to an Angus, we're going to decrease the performance or production of those. So again, the daughters are not necessarily as productive as their mothers, and we can think of that as a terminal cross, not necessarily just continental bulls there. Continuous system produces its own replacements, females, by keeping those heifers. You got maximum control over the genetics and management of those cattle. In the selection of sires, you got to consider both market and maternal factors though. So oftentimes in a continuous system where you're raising your own replacement females, you're kind of hitting in the middle. And so any undesirable maternal traits from the sires can be spread in the females. So you got to be real careful in your selection process. Applicable breeds should be similar and have a blend of important traits. So really extremes don't fit. So if we're trying to really jump our growth and performance of our calves, you may not be able to do it in a continuous system because, yes, the animals that go into the feed yard, they would have increased performance, but the females that you put back into the herd could be bigger, growthier, maybe leaner cattle and not as high performing. Continuous systems include straight breeding, so using purebreds or maybe composite breeds. A rotation is an example. A sire rotation is another example. So a true two-breed rotation would be, let's just say we used Angus, we breed them to Hereford. So you rotate the saved Hereford sired heifers to another breeding group, and we use the Angus. And you take the Angus sired and you breed them back to Herefords. And so what you end up with after several generations, each group is going to contain about 2/3 of the influence of the breed of sire and the other third of the other breed. Okay? Our sire, two-breed sire rotation, Angus and Hereford again. You return the heifers to the herd, change to Angus sires before going back to a Hereford sire to that breed there. Terminal systems, the heifers are not retained, so those replacements got to come from outside sources. And the outside source could be a different breeder that's breeding those for you, or it could be a separate herd that you have to raise replacement females. It's very specialized. You can't select for the extreme sire types because of that, because you're trying to hit in the middle with the maternal and market factors. The only system that can exploit strong points of a type and breed without having those weak points. And so that's what the terminal cross system does. And so two different types. We talked about the cystatic, if the replacement females are purchased, requires only one breeding group to implement the terminal cross. Otherwise, you've got to have two different herds. You've got to have your maternal herd that's producing the replacements, but then also your terminal herd. A rotational terminal type system is a combination system with a true rotation or sire rotation, from which the surplus females are used in a terminal cross with that. So example, of a static terminal, you purchase Angus Hereford crossbreed, and you breed these two, maybe a Charolais or Continental type sire. The rotation would be in one herd, you've got conduct a sire rotation of Angus and Hereford. So you move the older females to the other herd and breed to a Charolais for a terminal cross. Or it could be if you've got a Beefmaster herd. You've got a herd that you retain as a composite Beefmaster straight bred. The mature females go into a terminal system where we use another terminal sire, maybe Angus or Continental breed or something like that, or Maine Anjou. So commercial producers should strongly consider well-planned crossbreeding with full knowledge of the opportunities and drawbacks, because there's good and bad in all these breeds and how we influence and we use them today.